nothing else than DevOps. The setting is the following. I will give you a quick introduction to myself, then I will give you a first impulse. After that, we will have roughly a 10-minute discussion. Then I will give you a second impulse with another discussion of 10 minutes. And then the third impulse will be given, and then we'll have the final discussion. And roughly at 10:30, we will be over with this session. So quickly to myself, my name is Romano Roth, and I work for Zirke now since 20 years. I joined Zirke directly after university as a junior .NET engineer, became then an expert software engineer, then a lead software architect, and then a consultant. And one thing that was always at my heart was, how can we continuously deliver value? How can we ensure the quality? How can we automate things? And when the whole DevOps movement started, I jumped right on top of that. I became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup we are doing. Sometimes it's remote, sometimes it's in person. And I'm also one of the organizers of the DevOps Days Zurich, which is a yearly conference in Zurich with 300 people. And it's about, of course, DevOps, and it's over 2 days, and it's absolutely a lovely thing. The DevOps Days is sort of a franchise. You can see, you can find the DevOps Days all over the world in all big cities. And because DevOps is my hot topic, I also have my own YouTube channel with a lot of videos all around DevOps. I also tweet a lot or post a lot on LinkedIn. So you can always follow me and also take pictures of me and like me and so on. Nowadays, I'm working with different clients in different industries doing DevOps and agile transformations. So, what is the problem we are trying to solve with DevOps? So one thing that I usually see when I go to the clients is that the business, together with their clients, they have bright ideas. And they put these bright ideas into Word documents and into Jira tickets, and they throw it over the wall of confusion to the developer. The developer looks at that and says, well, if you want to do that, I can do that. And he hacks it in, throws it over to the build pipeline. It goes to the tester. The tester looks at the requirements, at the code, and says, that doesn't fit. But they test something, and it's green, and it goes to operation. Operation says, whoa, how can we operate that? But somehow they figure out to operate that. It goes back to the client and to the business, and they say, what is that? We have not thought of that. The problem which we have is these walls of confusion. They are usually because we have a style of organization, and it is also a lack of alignment that we have. And what you can see is that this is a value stream, and the value stream is pretty interrupted. Now, where do these challenges come from? Now, in the past, and I'm pretty sure you also did that, we had the waterfall process. Scope, budget, time was fixed. Of course, budget and time was always overrun. But anyway, we did plan, test, develop, deploy, review, design, launch, and then we launched the whole thing. Because that failed quite often, we thought, yeah, we are now going agile. And we said, yeah, because we're going agile, the scope is not fixed. And now we are working in smaller product increments, which was great. But the problem is we are still doing projects. And the project has a fixed start and a fixed end. And usually what we are doing is we build products. Now, it's all about products. What is the difference between a product and a project? And in my opinion, this is very, very important, because when we have a project, as said, it has a fixed time, it has a fixed scope, and it has a fixed resources that are allocated, and mostly we are focusing on the output, maximizing the number of features, the user stories, the source code, the number of stuff which gets delivered. When we go to a product, then the focus of a product is that we understand the customer, that we solve the problem of the customer, that we change the behavior of the customer. That's what's all about in a product. It's not about how many features we have. It's all about that we solve really the problem of the customer. So the focus needs to shift. Now, one way to shift this focus and build sort of a value stream that supports that is going with DevOps. DevOps is a mindset, a culture, and a set of technical practices which provides communication, integration, automation, and close collaboration among all the people needed in this value stream over plan, code, build, test, deploy, release, operate, and monitor. Now, when we talk about the people, then we really need to talk about the people, because DevOps, the term, says development and operation. And the term is not so good, it's not so good choice, I must say. Because there are, of course, people now out there that say, yeah, but we have forgot security. Security is very important. Therefore, we say DevSecOps, which is development, security, and operation. And then there are people out there which say, oh, no, business is very important. So they created the term BizDevOps, which is business development and operation. But DevOps is really about bringing all the people together, which are working on the value stream. So we need a term like DevSec, Biz, Arc, Comp, QA, Ops, or we can also call it DevStarOps or DevXOps. But in fact, DevOps is about bringing all the people, all the process and the technology together to continuously deliver value. That's what DevOps is. Now, the question is, why should you care? Why is that important for you? There were some small companies with funny names like Google, Microsoft, Facebook, Amazon, and they were doing software development in the year 2000. They were adapting the agile practices, lean practices, and of course also DevOps. And nowadays they are dominating the market. What we can see today is that there are companies like Tesla and SpaceX which are doing exact the same, but with hardware, with cyber-physical systems, where you bring software and hardware and mechanics together. And this will have, in the future, a massive impact also on us, because the whole market will speed up, which we will see in a few slides. Do you want to have an example? Here it is. It's from Elon Musk. You can think about Elon Musk what you want. But he was tweeting on the 7th of October, we are rolling out the new autopilot version. We are going with 1,000 owners with a perfect safety score of 100. What does it tell us, this tweet? This tweet says that Elon Musk with Tesla is able to make a canary release to a certain amount of people, which has a safety score. And having a safety score means that he is monitoring these cars which are driving on the road. It also means that he can do over-the-air updates to these cars. Then on the 15th of October, he says, yeah, everything was good with that version. We are going to roll out 10.3. This means that they were getting feedback from the cars, but also from the customers if everything is okay. And they are now confident to install the next version, and they even go with a bigger audience. They go with the safety score of 99, 100. And then on the 24th of October, he says, ooh, we found a problem. 10.3 is not a good version. We need to roll back to 10.2. Now we need to stop a little bit here, because here we have cars driving on the road, and Elon Musk is doing with his company a rollback of the software. Many companies out there cannot even do that with their normal software, but this is done with driving cars on the road, which is pretty amazing. And then, not even 24 hours later, he says, we found the bug. Now 10.3.1 will be rolled out. So he does a fix for it. So in these tweets, you see a lot of these DevOps practices, which we are using normally. And you see that Elon Musk is using that in Teslas, which are silent physical systems, which is even harder to do that. So what is then the benefit of DevOps? The scientists, they have looked at that. There is a great book, Accelerate, out there, which looks at the science of DevOps. And there are also these state of DevOps reports. And here you can see the 2019 one. And what they are doing is they interview a lot of companies and then they benchmark them. And they have 4 figures, which are sort of the benchmark. And here you can see the top performers, so companies which are doing DevOps, which are elite, versus companies which are not doing DevOps, which are the low performer. Companies which are doing DevOps, they have 208 times more frequent deployments. They deploy on an hourly basis or on a daily basis, versus companies which are not doing DevOps, they have 3 months releases there. These 208 times more frequent deployments come from. They also have a 106 times faster lead time. The lead time is the time from code commit until something is in production. So they are 106 times faster. They can do a code commit within, for example, within hours. A commit from a developer can go into production, versus companies which are not doing DevOps. There it can easily go 3 months or 6 months until this code hits really production. They also have a 2,604 times faster time to restore a service. Now, when you are continuously deploying, hourly deploying, then you need to have a continuous integration, continuous delivery or deployment pipeline, which is automated. Now, when something goes wrong in production, you need to automatically fix that. And that's exactly what they are doing. Everything is automated. Tests are run in production, and then a rollback will be automatically done. That's why they have 2,604 times a faster time to restore a service. Usually companies which are not doing DevOps, they take the server down on the weekend, fix the stuff, and then they bring it up again. They also have a 7 times lower change failure rate. And here, this is the failure rate when a deployment creates a failure in production, and they are 7 times lower because they have an automated build pipeline. And when you have that automated build pipeline, you need to have tests which are automated, and therefore all of the bugs are covered there, and not so many bugs are going into production. Now, when we look at the 2022 report, you see an acceleration. So the whole industry is accelerating pretty massively. And when you summarize this whole picture which you see here, then it means that when you are doing DevOps, then you have a better time to market, you have better customer satisfaction, and you have a higher quality. That's the benefits of DevOps. Now, DevOps is nothing else than modern software development or modern product development. That's what DevOps is, despite the term and all the hype around these terms. And when we look at the DevOps infinity symbol, which we have here, then we have the plan step, where we do the agile requirements engineering. And here it is very important to identify what the hypothesis is, what the leading indicators is, and how we can measure if a feature is successful. And I will come back to that. Then we are going into the agile software engineering. There we have all the agile software engineering practices. We use version control. Everything goes into version control. We go into continuous integration, which we will have a look at it later. Build and test automation, security is directly built in, and we have the test automation with the test data management. Then we are going into deploy. There we have a staging environment. Staging environment is a production-like environment with the test automation. And as you can see, we then have the canary releases where we say we release to a certain set of people in production. And for that, we use feature toggles. And here, a very important thing is that one of the core practices which we are doing in DevOps is we separate deployment from release, which means a deployment is bringing the compiled source code to production, but with the feature toggle off, and the release is switching on the feature toggle. This enables us to do dark launches, to continuously bring the code into production and then release when the business thinks the time is right. In operate, we want to have proactive detection. So we want to find the bugs before our customers do. And when something happens, and it will always happen, we want to do cross-team collaboration across this value stream. Finally, in the monitor, we of course need to monitor all of that. We need to have full stack telemetry, and we also need to monitor the business features, because now it goes back into plan, and we want to provide the business with how their features are used, or if their business case is valid. That's what is important, because with that, we can steer how many features are developed, and we can also leverage that we are not doing so much work in process. Now, this was the first impulse. And with that, we are going into a 10-minute discussion about DevOps. And the hypothesis number one is DevOps is bullshit. What do you think? Is DevOps bullshit? Completely overrated? Is this something you also do? This DevOps thingy, as I've shown?
Maybe sometimes a project is better. It really depends on your target. If you have teams living, then maybe DevOps is the right thing to do. But if you have a release stage set up, then sometimes a project with big start and big end is maybe better to not to have to learn to act as a team and to perform as a team, because it takes time. So not bullshit, but there are other methods which are still valid too, I think.
Yeah. What do you think about projects and products? Do you already have only products, or do you still live in the world where there are projects?
Oh, this is you're asking a painful question right now.
Good.
Because I think that definitely that the projects are killing DevOps because we don't have products at all. I think we're still thinking in a couple of bigger projects, and we have scheduled budget discussions. We do not deliver what you said features, but we have to keep goals. We do not leave existing boundaries. You know, about this has to be, this is a number, and it always used to be the same number, so we don't think out of the box. And I think with thinking in products, not having to deliver at a certain point of time because everybody's waiting for it like a branding party, then we have more options. So DevOps is quite convincing. It's not bullshit, but you have really to trust into going that way and then leave things that you're accustomed to.
Opinions?
We are still in change. We have some project approach, and we have some approaches they go definitely to DevOps. But there are still some walls that we have to break down, and probably some hurts from people. How to change? I guess it's not easy to get in fast time to really DevOps culture.
Yeah, this takes quite some time. It's a cultural change. Are you measuring already the feature and how features are used?
I think it depends from project to project. So we have like projects or products where even the business is doing measurements. Let's say like stuff on the website where it's like Google Tag Manager to find out like how many people jump out of a calculator. Or we have like more IT orientated metrics where we try to find out like, I don't know, how many Jenkins jobs have been run, things like these. But we don't have the ability to like really measure the success of certain features. We have it sometimes, but not like through the whole value chain.
And when you see that a feature is not used, are you also going to get rid of it, remove features, or even applications?
Definitely. We now are changing all software to new software, and we discover some things we don't understand, and then we ask, why is it? Do we need it? And in this situation, we really take permissions on future. We don't re-implement them.
Yeah. Any feedback from the
from the remote? I don't think there is any input. Remote, you can just raise your hand in Teams or write your question in Teams. You can ask the questions also in German in case you feel uncomfortable with English. Stefan, go ahead.
So let's try if you can hear me. Does that work?
Yeah.
Yes.
Good. Perfect. Well, I don't know if it's bullshit, but what I don't see is, as you said at the beginning, the DevOps is a mindset kind of. It's a culture thing. And the troubles I have is a bit is with the way to get there, because there may be teams or even half organization, part of organization, which may even be able to get that mindset and jump into that mindset. But in a company, I mean that the whole part of it is that we, as you said, it's about all. It's not about the developer. It's not about the operation. It's about the whole group. So I think if just a part of the team or so, which are example the developer, so maybe even operations are thinking DevOps and going into that mindset, but the rest is not. I don't know how it should work. And the point is, how do we get? I mean, maybe even the whole company doesn't want to change. So how do we get DevOps to run if that's not the case? So either we really get the whole company or we don't, or is there a way between that? I do not know. I have not the answer. I didn't work in a company yet which really does DevOps, and I think we don't at the moment.
That's absolutely a perfect introduction because that is exactly what the next input will be all about. It's all about how we get there, how we can introduce DevOps, and what is important. And this will be the next two inputs which I will give you. Are there any more questions? Because then I would directly answer your question, Stefan, by continuing. All good? Good. So the question is how we get from projects to products, or how do we introduce DevOps? Now, one of the most important things, in my opinion, is that whole system thinking. So thinking in the whole system, not optimizing only small parts of the system, clearly seeing the whole system. And now, when we look at that infinity symbol and also at DevOps, and when you think about your project or your product which you are developing, this is nothing else than a value stream. And I heard already that you have value stream, you have cross-functional team, and you have an IT goal to align across the value stream. But to really work cross-functional and across the value stream, you need to identify this value stream. And there, the whole system thinking comes in. And for that, we have the so-called value stream mapping, which we use in DevOps. And value stream mapping is a very easy thing. What you do is you have a group like this one, you have a bunch of post-its, and you bring all the people which work on this value stream, really all, not only the dev and the ops, also the business, the architects, the security, the quality assurance, all of the people you bring into this room. And then you say, okay, what are the steps which we need to bring an idea into production? And we put that onto the post-its, which means we have a post-it here. This is just an example: feature definition, design, code, test. Okay, then we say, okay, who is responsible for that step? Here, product owner, architect, developer, tester, and so on. Okay, now the magic happens. Suddenly, all of the people will see the whole value stream. And it's amazing when you have management or business in there, they suddenly say, aha, this is the whole value stream. I didn't thought that this part over there is so long, and this is why it takes so long. On the other side, you see the developers saying, aha, this is why it takes so long before we get a feature request. So you align the people. Suddenly you have visibility over that value stream. And then you go into the next step. You're going to measure now this value stream. And this is not an exact measurement. It's just rough estimates which you are doing. But you say, okay, we are going to measure PT, LT, and percentage completed accuracy. PT is process time, LT is lead time, and percentage completed accuracy is this percentage CNA. The lead time is the time it takes from finish of this step till finish of this step here. This is the lead time. It includes all of the waiting time. The process time is the real actual value adding work which we are doing there. So for example, when we look at test, then we see that we are really testing 8 hours. But the lead time is 336 hours. There is a lot of wait time in there. And usually you have exactly these times in your project because some deployments need to first happen. There is some waiting until all of the systems are correctly configured until the testing can start. And this is completely a normal thing which we see. What you also can see is this percentage completed accuracy. Where you also then see, or the percentage completed accuracy is a number where you say in how many cases can the next step use the output of that step as is. So for example, code has 60%. This means in 60% of the cases, testing can use the output of the coding as is. In 40% of the cases, it goes back to coding because there was a defect or something else. It gets very clear now where we have some bottlenecks in here. And you can already see them, and they are surfacing somehow. And with that, you can say, okay, now we understand how this value stream flows. We understand where the bottlenecks are, and now you can go and fix these bottlenecks. Of course, you then also can do the total PT, the total lead time. You can calculate the activity ratio, which is here 7%, which means we have sort of 93% error in that case here, which we have. And you can also calculate the rolling percentage complete and accurate, which is in that example here 5%, which means that in 5% of the cases, we go through that whole process without rework, which means that the total lead time will only be reached in 5% of the cases. In 95% of the cases, it will be lower. And the beauty about that is usually people say, yeah, that's exactly how it is in average. And then you can work on that value stream and work on these bottlenecks. Now, this value stream, what we have in here, this is nothing else than a continuous delivery pipeline. And for that, we need to understand some terms, because in the DevOps world, there are always these terms. And one of the terms is CI/CD. Now, to understand what CI/CD really is, we need to first introduce continuous integration, which is the CI part. So continuous integration happens then when a developer commits code into the source code repository, because then his or her code will be reintegrated with the rest of the code. That's why we call it continuous integration. Then the continuous integration server will take up that code. We will build it, we do the code analysis, static security analysis, unit testing, and integration testing. That's continuous integration. Very important, we want to have fast feedback. Not within days, not within hours, within minutes. The developer needs to be informed if everything is okay. Now, the output of the continuous integration is a deployable artifact. And now we are going into continuous delivery. Continuous delivery is then when we take the deployable artifact and we automatically install it in a staging environment, which is a production near environment. There, we can do either manual tests or automated tests, but the important thing is, again, to have fast feedback back to the developer. This is continuous delivery. Now, when we do continuous deployment, then we do everything with continuous integration. We have that deployable artifact. It gets automatically installed in the staging environment, and then in the staging environment, a set of automated tests is run. And if that is green, everything is okay. The deployable artifact goes directly in production. It is installed in production. And again, a set of tests is run. And if everything is okay, it's okay. And if it is not okay, then a rollback automatically happens. That is when you are doing continuous deployment. So doing CI/CD, which is continuous integration and continuous deployment, is really building on every commit, and every commit goes through that pipeline directly into production. The important thing is you don't need to do continuous deployment. You can also do continuous delivery, which is absolutely okay. But you need to be sure about these terms, because I see a lot of people saying, yeah, we have continuous deployment, which is quite expensive, and not in all cases you can do that. But you always need to be aware about these terms and what fits your needs and what solves your problems. That's the important thing. Now, such as CI/CD pipeline, a CI/CD pipeline can look like this, and you can see the toolings down there. These are the tools that you are using. Of course, perhaps your CI/CD pipeline can look different. They can look different from product to product or from project to project. But these are sort of the steps which you usually have in your continuous integration, continuous deployment pipeline, and how you use them. And this is completely just an example how it can look like. But when we talk about the continuous delivery pipeline, then we not only have continuous integration and continuous deployment, we also have continuous exploration and the release on demand. And it is very important to understand that this is the real pipeline you have, and you will have that, because continuous exploration is all about that agile requirements engineering, the ideation. So there you need to have backlog management. And when we look at the release on demand, then when you have feature toggles and you're doing release on demand, so you are able to do continuous delivery with feature toggles off, then you of course also need to have sort of a release management or a feature toggle management that allows you to do this release on demand. So this is a continuous delivery pipeline which fits to your value stream. Of course, there are products out there or vendors out there which say, yeah, we can do everything. So the biggest ones are GitHub and GitLab. They say, yeah, we can build the whole thing. What you see when you look closer to them, then you see, yes, they sort of can, but you need to replace some inadequate parts. And then it looks more like that. But the big benefit is you have a very good integration of the things and some nice user interfaces over everything. But you always need to be aware that you still have a lot of tools and you need to integrate all of these tools. Because you see here in the end effect is nothing else than sort of a conveyor belt, which goes through your product. And when we now think a little bit further, then each project or each product that you are delivering is sort of a conveyor belt in your digital factory. And here, factory, it's not the bad thing, the factory. It's automating all of the steps, industrializing all of the steps, standardizing all of the steps so that you can deliver faster your value. And it can look like this. And the most important thing is that you always have that feedback flow so that you deliver very fast value to the customer, get feedback, and have a continuous learning cycle, which are the 3 ways of DevOps. And with that, we are coming to the next discussion, which we will have about that whole thing that I have told you. And as an input, I brought you a hypothesis number 2, which is DevOps is dead. Long live platform engineering. What do you think?
I think it depends on like the size of your product teams. So for instance, if you have like a product team or product group with, I don't know, 80 developers, then you can like easily create each part of the continuous delivery pipeline, have all of the know-how in your team. You can run your own tools to deliver value. But if you want to go with smaller teams and you have like, I don't know, 5 to 8 people in a team, then I think it's going to get harder and harder to run like all of the pieces that you need to deliver software in kind of a professional way. So if we look at all of the tools that you've shown and you need to be like proficient in each one of these, then it could make sense that you have kind of one or a couple of central teams that create tools that help you creating your continuous delivery pipeline. And that's what I understand of platform engineering.
Perfect. That's it, yeah. Do you have platform engineering?
I would say so, yes. So we have like platform teams that run our OpenShift platform, that run our continuous delivery toolings, or that run like tools to do like integration or security. So we try to like move these things away from our feature or business teams, so that the business teams can deal with business features, and platform teams deliver like the IT business at the end of the day.
That's absolutely great. So you are doing that. Any other opinions about what was just said about the continuous integration, continuous delivery pipeline, or what are you doing? Are you doing continuous deployment or continuous delivery?
We're mostly in continuous delivery because we have some big issue that we are allowed to do continuous deployment. We have this internal control system that requires us to that we need a manual sign-off before deploying into production. And so by definition, we cannot continuously deliver, at least not for the relevant applications.
Okay. Why?
That's a good question.
Traditions.
Traditions.
It's like the DevOps spirit. Let's say it's not in all the levels of the company at the moment. My personal feeling, it's a little bit IT driven, and not everybody likes that.
Okay.
Well, I'd even say we don't do continuous delivery.
Well,
So if you have a
not
look
every.
at but if you have a look at applications and their pipelines, and if you count like how many of these applications that we have get automatically deployed to a environment, and let's not say staging, let's start with like dev test or something. I'd say it's under 5%.
But there is at least some movement there. And I think that we went from like monthly releases to several releases per week. No, so that's already an improvement.
Yeah, it's a continuous improvement cycle which you are doing.
But is it even possible to do continuous deployment in a kind of finance or a highly regulated industry where you need official sign-off for everything for the reviewing companies? Because they have to see everything and see that everything was signed off by the business. Is it even possible to do that?
Yeah, it is actually. The thing is, what you can do is you can do a small experiment with the people in your organization. What you can do is you can create some bad code, just some bad code, or some bad features, and bring that into your source code repository. Of course, there's the feature code, but it's still bad code. And then you can move this code through your organization. And usually you have a release management business that should check. And with your monthly releases or 3 monthly releases, it goes into production. And with that, you can show them that all of these security measures that they are having are nothing but. And that's what you usually see, because it's quite normal. Release management cannot look at all of the code that you have, and business cannot look at all of the features you are doing. And it's so much change happening usually in one release that one person cannot look at that. So the solution for that is that you automate a lot of stuff. And here we are coming to this continuous delivery pattern, which I showed you. When you are able to make static code analysis, static security analysis, have regression tests fully automated, then this is far better than having some people that looking at Jira tickets, and if the Jira ticket is correctly formatted and checking that, then if you have that, then you have a lot of problems. And when you look also at the book Accelerate, they have that also in there. So if you have a CAP or a release management, they can clearly say to you that science says if you have that, you have a not so fast software delivery performance. This will hurt you. And the best thing is, sorry to say that, to get rid of it. So science says, don't do it. Do continuous delivery or continuous deployment so that you get the software delivery speed. With that, we are at a very good point because
there's a question from a remote. Sorry.
Yeah, just to make that sentence, to close that sentence. it is very important to understand what are your needs. So how fast does your business need to deliver? That's very, very important question. And you always need to ask, and it depends on the product, but I'm pretty sure you don't need to release or deploy within hours.
Yeah, Stefan?
Yeah, I understand actually the point you give there. But the question is, again, back to regulations. The trouble is sometimes I guess it's not only the companies, not only the teams which need to be involved, it's also the regulation, I mean, law. Now, I think if there is a law for financial institute to do certain measures and they still live in the old world, how can we go to a new world, to a new thinking if well, it breaks basically law? Or yeah, that's my question basically.
Yeah.
How can we do that? Because
it's quite simple. The thing is, read the documentation. It's very hard, but I also encountered that in the financial industry. They always said we need to have segregation of duty. This is by law, and the regulator demands it. Yeah, well, I went to the regulation, to real regulation, and read through that, and I thought, yeah, there is nothing written there that it needs to be another person. It's just you need to make sure that the developer cannot directly deploy into production. So that's what is sort of written there, so that you have sort of a 4i principle, so that no one can introduce bad code into production. So the regulator usually wants to solve a problem or reduce a risk that you have. And you need to understand this risk and this problem, and then come up with a solution. So I also came up with a solution, but that was not enough, because there was also, I think it was KPMG, which was reviewing all of these regulations. So we also needed to convince them, but also there, when you say, look, the regulator wants to reduce this risk and or this problem, and we have that solution which is fully automated, and we are going to document all of that, then they were also saying, yeah, this is far better than having a person checking source code and not understanding it. So that's how you do it. It's really read the documentation. Does this answer the question?
yeah, yeah. Yeah, for sure more, but I stop at there.
No, you can. We have enough time.
No, it's all right. We'll need to do discussion somewhere.
Any more questions or points on your side? Then I have a question to you. So we talked about continuous delivery and continuous deployment. What do you think? How fast does Baloise need to deploy? What should be the deployment frequency?
Depends.
Good answer.
Do that on purpose, right? Yes. I think this current situation is that we have a hierarchical business and an agile IT. And in IT, we think we have to deploy as fast as possible to deliver. But deliverables needs to have an expectation. So how fast does the business expect us to deliver what they expect, and do we deliver what they expect?
Yeah.
And the answer is, yeah, we don't know.
Have you asked business?
We experience that. You don't have to ask them that. So we have a policy center, we deliver things because they demand it. We don't deliver everything they need, and also sometimes the changes are that big that they do not really can follow the changes. But we have a release cycle every 2 weeks.
Okay.
So it's like a pipeline. We have to again and again, and I would expect that most of the customers and users do not really understand what has changed. They do not even read the release notes, although it's their original way they raise the requirements.
Is Is someone from the business in the call?
Hopefully not.
That's DevOps. Perhaps I should call it this DevOps then.
Next time.
Next time. Oh, good. Okay. Any more questions?
Yes, perhaps.
Yeah.
I don't think that very often that deployments in production have to be very often. In our case, once daily or once per week should be enough, probably.
Mhm.
But the lead time for bigger issues is way too long. It's months, years even. And this is a big problem, I think. We have big projects which block everything else, and we're not able to make smaller pieces that can be delivered faster.
Yeah.
So I think business is really happy if you can deliver something next week or in 2 weeks, but not next year or 2 years. That's my impression of the scales that are involved.
No.
Yeah, because in the next month they have 3 cool new ideas. You can expect us to be finished with the ideas there this month. That's fair enough. That's what you call agility. They have to, from my perspective, I would love to satisfy these needs to become agile from this perspective. But as I mentioned, they are large projects instead of thinking delivering small chunks. We just call it a 3 years project. We even shift the due dates because we have strategic conflicts. And I think that approach does block us from many things.
No. Here, of course, what you need to have is sort of a portfolio with clear, let's say, initiatives where you define MVPs.
We have. I think the problem is that we think too big, that we do not leave our ancient traditional technologies and methodologies, how we achieve this goal. We think we need a big project, we need the best people on the project, and we block everything for that. And if it's not possible, then we shift the days, and then again, the whole team needs to be in the new project. But we do not think about delivering small chunks. Instead of taking a small branch, like travel insurance, we think about the NF, the biggest thing we have, because we have the biggest benefit in there. So we have to rethink about delivering continuously, integrating continuously, taking the existing systems and changing front end, for instance. Going back, it's my tiny pieces way instead of big things. That's my purpose.
It's all about output versus outcome. So business is output oriented. That's the problem. They should go into the direction of being outcome oriented, solving the real needs of the customer. And you can also do that with smaller items. They are not so shiny, but they solve the problem of the customer.
What the person said to me in a pipeline, I want you to make the world a better place every day a little bit. Perhaps that sounds somehow naive, but on the other hand, it's not that bad, that attitude to have every day a little bit improvement.
Yeah, Stefan, you have a question again?
Sorry again, but I want to jump into this little thing and big thing. It just came to my mind now. We had Tesla before. Now, yeah, we saw this continued delivery in upgrading the software they have on the car. But now Tesla has also some projects like introducing, I don't know, what was it? Was it a van or was it the big car? I mean, they do also such things. So how does that integrate into that whole thing? Because they have big project. I mean, they wouldn't live without big project. I mean, the first one was even to deliver the first Tesla, and that's not done by little pieces.
Yeah.
Or is it?
Yeah. When you look at Tesla, and you're absolutely right that at the moment I think it's called the Cybertruck or so, and
Exactly that one. I mean,
2 years ago, still it is in. And yes, until it really is released, of course, it takes quite a long time. But I'm pretty sure what they are doing, they are now constantly iterating over the production line. So they usually have a production line. They are already building Cybertrucks, but they are not selling these Cybertrucks. They are just going through this production line. When you now go back a little bit to the Model 3 that they are developing, what you can see there is that the production line is running. They are releasing these Model 3, and every Model 3 that comes out of that of this pipeline is sort of a new release, and this is also quite amazing. They are making, I think it's 10 changes per week on hardware and software in their production line. And that's quite amazing, because you usually, when you look at other car manufacturers, they are not doing any changes on the production line. It's always the same car. And at Tesla, all of these cars are not anymore the same. And you also need to handle that in a configuration management. So yes, they are continuously deploying sort of, and they are releasing on demand. So when the Cybertruck is sort of finished and the pretty sure business or Elon Musk says, yes, now it's the time to really release it, then they will begin to sell. Until then, this factory is just running and producing some parts, which are increments of a Cybertruck.
I think what is also a difference between a product and a project is that a project is at some time it is finished, and then focus shifts away, and then like the project is done, what implies that the product is done. But if you have a look at products, you want to incrementally improve them. So even after like your big release and you like have the product out in the world, you want to continuously measure and improve. And on the other hand, if you do like big projects, what happens after a couple of years without investing anymore, you have to create the next big project to like recreate the whole product because you haven't invested during the last couple of years.
Yeah.
Then you are in this in this project cycle, and you always get like big projects, and normally they tend to get bigger and bigger, instead of like continuously investing and trying to figure out what are the products which we need to improve.
Absolutely, I see that quite often, and that's why you need to have that product thinking. And also, when you now look at all the security risks which you have, a project is something that never ends. When you have a product out there, you are in the need to constantly upgrade this system. Always check for security vulnerabilities in the source code, in your Docker images. You need to have that pipeline always running so that you can bring a new releases of the software out. Yeah, probably also had that problem with Log4j, was it? Which was a huge problem. And if you don't have that pipeline running, you lose quite a lot of time, and you also have a high risk. Good. Then let's continue with the last part. So now we have that continuous delivery pipeline, and what we want to do is, in this continuous delivery pipeline, which is already automated, we want to build in quality. And to build in quality, we need to understand a little bit how projects are building in quality and how we should do that in Agile. So when we have the classical projects, then we have the classical V model, which you can see here. So a business analyst writes a feature at a certain point in time. Then perhaps another business analyst, after some time, will write a story out of that feature. And after some time, a developer gets to that story, and he or she will write the code. If we are very lucky, he or she will also write a test afterwards. If you are not so lucky, which is usually the case, he or she will not write any test for that, because there is a lot of stress and feature pressure, and we need to move on. So what happens usually is then you have a QA, and the QA will then test this story. This is also why the developer doesn't need to write the test. And after the testing of the story and some back and forth, another QA or the business will then test the feature. That's how traditional V-model testing looks like. The problem is between writing the feature and testing the feature, it can easily be 3 months, 6 months, a year, absolutely easily. And this is a delayed feedback which we are having here. It is following a plan. When we look at agile testing, then the feature is already written in a form with behavior-driven development, which it gives us a form where we write the acceptance criteria in a given when-then form as examples. This makes it quite clear what the feature should do. Also, the story is written in that form. And when we then go to the coding, the developer, he or she, can just take out this BDD form and put it into the code. And now we are at a very important point, because with that, the developer is enabled to make test-driven development, which is a test-first approach. So he or she can test before the actual code is written. So with that, we are creating a lot of tests out of that. But the big benefit of that is that when you look at specification, usually when you have a Jira ticket or a Word document, in that very moment, when you click the save button, this specification is outdated. When you are using behavior-driven development, we move the acceptance criteria out of the Jira ticket into the code. So the specification is as near to the code as possible. That's a very important point. And when you are executing these tests, then you are executing all over the time the specification. So that's a very good practice. This means that the code is tested, and this immediately means that the story is tested, and it immediately means that the feature is tested. So that's the whole point about shifting left. That's the core. What shift left means, it means we build in the quality right from the beginning. So when we go into automating tests, it is very important to say not all tests need to be automated. Easily automated tests are unit tests, component tests, and so on in this first quarter down there. Then rather easy in the Q2, you see A/B testing, story testing, user experience is already difficult, prototype simulations. There you can do some automated tests, but also manual tests. And then we have the exploratory testing, workflow testing, system integration, usability testing, and user acceptance testing. These tests are sort of difficult to automate or expensive to automate. For example, exploratory testing is something where you, for example, need an AI. Facebook is doing that. You need to invest quite a lot of money, and it doesn't make sense. But you can automate some of these tests, and down there in Q4, you see a lot of tests which can easily be automated by tools, performance tests, load tests, security tests, or the quality attribute testing. This is easy automatable, but it usually gets forgotten. So as said, not all of these tests need to actually be automated. Talking about the testing, we also need to talk, of course, about the test pyramid. So when we have projects, then the test pyramid looks like this. You have a lot of end-to-end tests which are executed manually in large batches. Then some integration tests happen manual and automated, and you have only a few unit tests. What is important is that unit tests are cheap, and the higher you get, it gets more expensive, and it also gets slower to execute these tests. And the focus in projects is usually to find all of the bugs. We want to get rid of all of the bugs. When we look at the agile test pyramid, then it is inverted. We have a lot of unit tests because of behavior-driven development and test-driven development. We generate a lot of these unit tests. We have some integration tests and only a few end-to-end tests. The focus here is on preventing the bugs. So there we go into a risk-based approach where we say, okay, which parts of the software need to really run? So this is business critical, and which parts are not so relevant, and it's completely okay if there is a bug in there. That's how we do the agile testing. This brings us again back to our infinity symbol, which you can see here. So in the plan, we're doing behavior-driven development, this given when-then form, and we have a clear definition of ready. So when is a story ready that it can go into the coding? We use test-driven development, so a test-first approach, always write first the test and then the implementation. And then, of course, when we are going to build, we execute the unit test, we do static code analysis so that we can ensure the code quality and also the language features. Then in the testing, we use definition of done. So when is the story really done? Test automation is important, and then the test data management. It is very important to have a set of synthetic test data so that you not have any flaky tests. So don't use the production data for your test, use synthetic test data. And then we are going into deploy. And here, when we are deploying something, we again execute a small amount of tests, which is well defined, and do production testing. So we execute tests also in production, of course, with synthetic data and synthetic transaction. Then when we release, we do cross-team collaboration during the release, and in the operation, we of course need to do proactive detection so that we know what the quality is, and we need to have a continuous monitoring on the non-functional requirements because they also need to be tested. And that's something we do in that monitor step, which is very important for architects, that having these non-functional requirements defined and also continuously monitored so that we can make sure that they are still in a good place. But with that, it is not enough. We also need to build for operability. And here, you may have heard it, it's you build it, you run it. And this does not mean that every developer needs to do first level support. It just means that we are doing cross-team collaboration. It's all about having all of the people on board and working across the value stream. For that, we need to have a monitoring system in place with alerts, with tolerance thresholds. We, of course, need to practice disaster recovery because disaster will always strike. The ugliest thing that can happen to you is that you have sort of a disaster recovery manual. And in that point where you need it, you first need to find the manual and then you find out it's outdated. So you need to constantly practice also these disaster recovery procedures. You need to have a notification strategy. And as said, it is very important that people are working together, not against each other. What you don't want to see is that you say it's ops problem and ops should take care about these problems. It's really about working together to have a great product. And when something happens, you want to do an incident post-mortem so that you can continuously learn. That's a very important factor, this continuous improvement and continuous learning cycle. This brings us to the monitoring topic. And for that, I brought you this slide to get you sort of an overview how that also has evolved. When you look at the typical system, then the old systems are sort of database centric. You have the user interface and the database below. So the database was sort of the holy cow. And at that point, you had metrics, CPU, memory, disk space, and you have logs. Logs are that what the developer writes out so that he or she can monitor the system and see what's happening. So really, this was sort of, in these typical systems, the monitor. So this has now evolved because now our application, and I'm pretty sure your application are also sort of three-tier application. There you have different user interfaces, perhaps a mobile, you have an application server, and then behind that you have a database. Here now it's very important to see some traces through the system. And for that, you then use application monitoring. You need to have some ideas that you can say, okay, this request was coming from that user over this mobile application through this application server into this database. And of course, you also need to have infrastructure monitoring because you now have bigger infrastructure. And then we are going into the distributed services. So with microservices, you usually have multiple user interfaces, perhaps also some APIs. You have API gateways, you have the different services or microservices or whatever you have. And now it gets difficult. When you have application monitoring, in that case, you usually deal with a lot of data. And you need to bring sort of these data together. And for that, you are using observability. There are great tools out there. I've heard that you are also using Dynatrace. This is a very good tool to get this observability into that. So that's how you do the monitoring. And this brings us again to the infinity symbol. When we are going to plan every feature that we are doing, every user story that we are creating, we need to think about how are we going to operate that. So every line of code that I as a developer are going to write, I need to understand, okay, how will I operate that? How can I make sure that that works in production? Then when we are going to code, we need to build in application telemetry. All of the infrastructure should be as code, so there should be no manual configuration of any server. Everything should be in the code, also the documentation, all of the requirements, all of the configuration, everything needs to be in the source code repository. Then we have the continuous integration pipeline, which builds everything, build and test automation in there with security. Then again, the test automation and the test data management. And when we are going into the staging environment, we build the staging environment with these configurations that we already have in the infrastructure as code. We go into the deployment automation. And of course, we also have the feature tokens. And here it's important, these feature tokens can then also be used to switch off certain features. If a feature is not behaving good in production, we can also have a kill switch to switch it off so that everything works again fine. And as said, when we operate the whole thing, we want to have cross-team collaboration. We want to find the bugs before our customers do. And for that, we need to have a full stack telemetry, which not only includes our small application, it needs to include all of the applications so that we can monitor all the application and the infrastructure so that we find problems faster than our customers. Yeah, this brings us to the summary. So what we just learned is that we need to go away from the project thinking to the product thinking. We need to go away from the output thinking to the outcomes thinking. So solving the customer problem, thinking in how can we change the behavior of our customers. Then we saw that this whole value stream which we are having is a value stream where all the people are working together, and we need to apply that whole system thinking. We need to have clarity on that value stream. We need to show it so that we can improve it and identify the bottlenecks. This value stream is nothing else than a continuous delivery pipeline where we have a lot of automation in there. And we need to be aware about this automation, and we need to deal with this automation, perhaps also with a platform team. And we build the quality directly in so that it can be executed automatically and that we can ensure the quality all the time. And the whole thing always needs to be built for operability so that we can operate these products. And this, all of that brings us to the point where we can create very good and great products. And with that, we are going into the third and last discussion. And here I brought you a third hypothesis, which is devs don't want to do ops. What do you think? Is that true?
I think it's true. If the outcome of the devs is as good as expected, there is less ops needed. But it's the reality. Ops is always needed. It's just a question of how much. But less is more.
And if development would develop absolutely perfectly, would ops still be needed? And who would use devs?
Yes.
And there's a question from remote, Dane.
Yeah, I'm not sure if it's the right place, but what's the point when there's you need to build up a lot of skills for every team? So every team needs to have a full plate of skills like monitoring, like Kubernetes stuff, and so on. How do the team manage to do such high or such many skills to manage it? You need to have very good educated people in the team, or is it okay to have just a small bunch of knowledge in some area and have a lot of them?
Yeah, you're addressing a very good and valid point. It's about that cognitive overload, and you see, when you want to do all of that, this is really a lot of things or a lot of skills you need. So there is a very good book also out there about team topologies, where there are solutions for that. We already discussed it. You can build up a sort of a platform team. So in bigger organizations, you usually have a platform team which provides some services, so DevOps as a service for your teams, which means you are going into the direction of having some standards which the teams will follow. And with that, they have an easier task. For example, then they get monitoring out of the box. All of the KPIs are already well defined. So they don't need to do that much, but they still need to have that understanding. When you look at the software development, what I can see is the complexity is rising, but also the standardization is rising and the industrialization is rising, which means we see a strong trend into the direction where we have sort of standards in our products, so that the teams don't need to deal with all of the complexity. So that's what I see at the moment, and how you should or how you can deal with that. So we are more and more going away from, let's say, every team does it their way and they have all of the knowledge in there to do it. And for example, one team uses a Jenkins and perhaps Dynatrace, and the other team is using TeamCity and then perhaps Honeycomb for the monitoring. So it's more about getting a sort of a standard, educating the teams, getting support for the teams by platform team. Does this answer your question?
Yeah, I think so. Thanks.
Regarding operations, well, I'm not sure whether it's like devs don't want to do operations. I think it's rather whether you are responsible for the thing that you have to fix. So if you introduce a bug and you have to fix it, like even outside of business hours, can be okay. But if it's like you have to do like on-call support because another system is doing their yearly big release, then you might think, well, why do I have to kind of do operations on Sunday, even though like my system should not be like tackled by this, or you have like big infrastructure upgrades, like I don't know, Linux patching or something like this, where you also say, well, I can't do the patching on my own, so why should I do like on-call support or operations or whatever you call it?
Why should someone else do that?
Well, it's I would say it's if you're responsible for something and like your responsibility is database management, then you do like database operations, and you can easily do your fixes in business hours if you can do it like live in production without downtime, like zero downtime deployments and stuff like that. And I think everyone has to decide on their own. So if you want to like invest in your continuous delivery pipeline, you have it set up, then you could easily say, well, we have like self-healing in our application. There is no need to do like call support at night. And then I can understand that devs say, I don't want to do like operations on the weekend because we have like automated everything.
And that's the whole point. You need to architect for operability. That's very, very important thing. So as you said, you need to decouple as much as possible where it makes sense, so that your system is not so dependent on other systems, so that you don't need to do that on call support. That's how you do it.
Isn't the whole thing a cognitive overload for the business owners or for the product owners? Because we said before we want to have business more involved, so we would like to have a PO which is from the business side, and now he has to decide, or she has to decide about upgrading libraries, setting up some monitoring tools. Isn't that a cognitive overload for product owners?
Yeah, it can be, but in my opinion also, you're developing a product, and product includes also how you build it. And so also these people need to understand how such things are built. But what you usually have is you are doing safe. So you have a solution architect in these teams which supports the product owner or the product management in creating exactly these products. So he or she, this solution architect, will then create the architecture runway, also prioritize backlog items, and look at the continuous delivery pipeline so that it can be built up, so that the product management or the product owner doesn't need to care that much. But in my opinion, product management and also product owners need to know enough about our system and our products and how they are built. So they need to have sort of an education in what form ever, that they understand how these systems work.
Yeah, I think we talked on the operation about non-functional requirements, and I'm just wondering, asking how many of you guys in the team here in the room, how many of you plan local performance testing in each of your pipelines? When you planning, you focus on features, the product owner is pushing you into features, the customer is pushing you into features, but how many of you say, I really know what this affects on my code? Because I didn't experience about that very much, that we have a local performance testing tool, and also planning that we say that the definition of done means we say it's tested. The solar key is tested in customer coverage, and we know what is the behavior in operations.
Well, I'd say in many of the cases you just don't need it. So if you look at our server landscape, it's like just idling around. So what's the difference if you get like 10 calls per minute or 50 calls per minute on your Spring Boot application that runs 50 replicas? So it's idling around with 10 calls, with 50 calls, with 100. I think we have to identify the bottlenecks. So like measure first, where do we really have like performance problems? And then you can do like, in my opinion, automated performance or load tests. But I wouldn't say it has to be the default for everything.
I totally disagree with that. I think building on a clean base, your foundation, what you have today is not what you have tomorrow. I think tomorrow you might have a couple of different services additionally. Your pipeline changes. With that, if you have a suboptimal situation, you will degrade it. Then you have to do refactoring. Think about the guide web platform. We have 3 nodes, everything's fine, and we don't care about performance and stuff. And all of a sudden, we have a renewal taking load several hours per night on a complete landscape. We didn't expect that. Now we have to change things, I think, and then it's too late. So I think knowing about being in the driver's seat, being in the cockpit, seeing how fast you are, and knowing when your system breaks, I think it's very valuable information.
Coming back to the statement, devs don't want to do ops. I think, as you've shown us the value chain, I think it only addresses a tiny part of the whole thing. And maybe the statement comes from the early days of DevOps. And looking at the value chain, yes, I think it's just not that important if you see the whole picture. For me, the big problem is how to get this idea of the DevOps, which is not only development and operations, to all the people which are involved in the product development, even business people and non-developers and so on. And I think from my point of view, this is the biggest problem. And I could guess from the title of this keynote, not many business people will join this session right now, even they should do. So I think the first problem which we should address is to get the people involved in product development aware of that and to have that as a foundation if we want to go in this direction. And then this is just bottom up. This devs don't want to do ops. It's just an unimportant problem at the moment.
Yeah. Very good. Yeah. But one first step of what you could do is do the value stream mapping together with them, so that they understand.
Yes, and I think you can't do this bottom up. It must be, the organization of the product development needs to be aware that we want to go all together in that direction.
That's what we do.
Over there was a question.
Just for his point, I will keep repeating system. We bring the new features into production, but parallel to the old system, and we don't switch the toggle. We just look at it, how it behaves, and we check differences between the old and the new system, and then we adjust the new system until it's bringing the same results. And then after 3 months or 2 PIs, then we switch it on. So that's our way to measure performance, to measure correctness. And maybe that's not I think it's not something very fancy, but it works.
But that's not new features, that's just the replacement of an existing system with an identical one.
Yeah, that's true. But the very complex ones, yeah, sure. That's
Yeah, there's a question from the remote.
part of the DevOps. You have to maintain the lifecycle. It's not only feature enrichment, it's also lifecycle management. You have to change some old things, replace with new ones. It's also part of the product lifecycle.
We have a question from the remote side. Juicy?
Yes, thank you. I have a general question. I mean, you said a lot of accountability. I mean, you build it, you run it, and cross-functional team, like end-to-end accountability. But you didn't mention anything about financials. Does the accountability also include financials in your eyes? I mean, cost of value. Is a cross-functional team should be also accountable for the cost of the whole system? And or do you say, please keep financials away, don't bother the team with costs? What is your opinion on that?
The answer is quite simple. Yes, of course, also costs need to go into that. As I said, it's about product development. So these value streams or these teams, they need to get the money so that they can operate their system and also do the change. So it's the change and the run. They need to have a budget. And with that, you give them also the ability to optimize in their way. So they then also can decide whether they are going to shut down some systems or if they are going to operate, for example, or go away from virtual machines to Kubernetes because it's more cost efficient. It's very, very valuable to bring the responsibility about the costs directly to the team. So it's all about value stream funding. So when you are doing SAFe, it's all about having the lean portfolio management and then also the lean budgeting with value stream funding in there. Yeah.
Thank you.
From my opinion, the most important factor is the human factor, as we discussed before. Sven said, Dane mentioned it. And we know these concepts. We know these concepts since 2-3 years. We foster it also with our IT strategy and so on. But this is a huge culture change. Don't forget the people. It's not done in one day.
Yeah, absolutely.
It's a way we are walking.
Yeah, it's not a sprint, it's a marathon.
Yeah.
It takes quite, you need to take your time. So when you look at culture change, people are usually saying 3 to 5 years. But you need to constantly work on that, continuously improve into this direction, step by step.
Like often it's also about like not doing things like only half the way. So if you look at financials, well, you can say you're responsible for like infrastructure cost, but like what's in it for you if you save cost? Like, do you get budget to hire someone and you can decide on your own, okay, if we improve our infrastructure and it's more cost efficient, then we have like money left to do other things with it? Or is it just like, well, there's like budget, and if you need less, then money is gone in someone else's pocket, and then the motivation might not be that high to take over like responsibility for financials?
Yeah, Stefan, you have a question?
Yeah, I mean, well, it's not a question, it's a bit of a summary or statement, which I just want to see if Michael approves it, because I see DevOps often is very driven from the developer side. But my statement here would be, like you did a couple of statements before, is developers can't do DevOps. And it's not because they are not capable by themselves, they don't want it or so. It's just the lack of the whole chain. So the developer can't do it without the rest. And that's a kind of a statement, and maybe something which should go into that, into our company. It's also a kind of a statement, if you really want to go that way, don't leave them alone, because they won't be able doing it. And also the rest, also the operations, even if we want to align with that, we will not be able to do that. We will not be able to do without the rest. So that's, I don't know how much you would agree to that statement or not, but that would be my statement.
Fully agree with it. Thank you very much for that statement.
But it, in our case, it was a little bit like the developers want to do DevOps, but the operators didn't want. So you go there and say, hey, I want to have read access to our Linux servers. Hey, we want to be able to start and stop servers. Typically, you're not greeted and welcomed. It's like our job. We do that, and do the development stuff. It took a long time until we had what we have now, so that we can start and stop everything with Jenkins. We can go and look on the server. Now it's with the current situation, we're losing a lot of this stuff again, but it's
typically also changes that need to take effect on the operator side and have to give up some stuff and give it to us.
Definitely. It's also about what are the goals and where is the line of the operators and is the goal of the operator team. Usually what you can see is, and I see that quite a lot in banks, that you have a development team or product team that is incentivized by number of features they can deliver or number of products they can deliver. Versus the operation side, they have KPIs, which says, for example, if you reach that number of bucks or if you are below that number of bucks, then you get an incentive or a bonus. And if you have such systems, they cancel each other out, and then you have a lot of trouble. So what you need to do is also work together with them, bring them together, perhaps create a virtual team, or even change the organization so that the goals are aligned. It's a lot about alignment.
As a developer, I feel quite comfortable to do OpenShift and deployments, blah, blah, blah. But when it comes to databases and disaster recovery, reorganizing tables and stuff, I just don't have the knowledge, I think. And we have less and less database engineers. So how do we tackle this?
It's the same problem with the platforms that we said. So either you bring this knowledge into your teams, so you hire people or you educate people in your teams if that's important. And if you cannot do that, then on the company level you need to have some teams that can support the other teams as platform teams to do that. And another thing is to think about, do we really need such systems with tables? Are there other technologies out there which we can use which make life simpler? Kafka. Kafka is not the simple one. Good. Any more questions? Good, then thank you very much.